Hello everybody, welcome to this video about naming acids, which is a super important component in chemistry. If you're studying chemistry in high school or college or Hogwarts or wherever the heck you go to learn stuff, then nomenclature, which is naming compounds and molecules, is a very important part of chemistry. And naming acids is another important part of nomenclature. And so you probably passed by this video, and now I'm gonna start saying useful things and stop saying useless things, and let's begin. First, I just want to start with this quote that I just found because I happened to stumble upon it on the internet, that says, "The expert in anything was once a beginner, unknown." So that just kind of creates a layer of mystery, which we are not going to be studying today. Now, let's go. Naming acids. Now, I want you guys to be very excited before we start this, because it is actually fun once you get the grasp of it. Naming acids. There are 3 separate cases of naming acids that we are going to visit in this video. And I'm going to draw a smiley face to hopefully make your mood better. Case number 1, eins, which is one in German. Why not? You're learning 2 things at once. So, first of all, I just want to, before I really get into case 1, I want to remind you at this point what an acid even is. But we're not going to go deep into the definitions of it, definition of the 2 separate definitions of an acid. But remember that an acid is basically a substance that I'm going to draw that once dissolved in water, now this is going to be my water in a beaker or in any other substance. This is my water. Once we dissolve our acid in water, it will release or break up into an H plus ion and some negative ion. So an example of this would be, for example, HCl, which is in fact an H plus ion and a Cl negative ion, just sticking together because they have opposite charges. And remember, opposite charges attract, and so these 2 opposite charges will attract to make HCl. So this would be H plus and Cl negative. And once we dissolve this substance into our H2O, it will break up into an H plus ion and a negative ion. In this case, Cl negative. I also want you to remember that a negative ion is called an anion. And a positive ion, meaning an ion that has a positive charge, for example, Al plus 3, aluminum with a charge of plus 3, meaning that it's lost 3 electrons, or for example H plus, as we just saw, or Ca2 plus. Sorry, this should be 3 plus. Yeah. All these suggest that these atoms have lost electrons. And so a positive ion is called a cation, or some people say cation. But cation sounds weird to me, so I'm just going to say cation. And I hope that you don't sue me for it or chase me down or anything, because, I mean, just a name. So let's not go too much on a tangent here, and let's go back to case number 1 of naming an acid. Case number 1 is when you have an H plus ion, meaning hydrogen, and a negative ion attached to it, and the negative ion does not contain oxygen. For example, I just gave an example here, HCl, in the H plus ion stuck to a negative ion, and this negative ion is Cl negative, and obviously Cl negative does not contain oxygen, right? Another example would, for example, be hydrofluoric acid, which is an H plus ion and a fluoride 1 negative ion. So basically a positive hydrogen ion and a negative fluoride ion will stick together to make this acid. And there's many different examples that you could think of. I'll give another one. Hydrocyanic acid, and we'll learn how to name these in just a sec. I'm just giving examples, so don't give up on me yet, because I'm not giving up on you. And so this is called hydrocyanic acid because this hydrogen is an H plus ion. The hydrogen is always going to be H plus in an acid, and well, in the acids that we're studying right now. And this is actually a polyatomic ion, which you are supposed to know by your heart at this point. If you're at naming acids, you should know the polyatomic ions by heart. This is actually a polyatomic ion called cyanide, and it's a molecule where the entire molecule has a charge of -1. And now let's go and name acids. I'm going to do that in the little corner right here. Basically, when, for example, HF, HCl, whatever, HCN, you could also have many different more ions, acids that have a negative ion that don't contain oxygen. In this case, what you're going to do is you're going to have the root hydro. You're going to have a hydro in front. Then you're going to have the root of the negative ion. Root of the negative ion. And then just ic at the end. And then just write acid. Now, I know this might sound a little complicated, but I'm going to show you an example right now. I'm going to use this different color. For example, let's do hydrofluoric acid. We have to write the hydro in first because this acid does not contain oxygen. The rule is that we write hydro first. Then we have to write the root of the negative ion, which in this case, we are already stated that the fluorine in this acid is a fluoride ion, so it's negative. Right, and so we have to state the root of the negative ion, which the root of fluorine is fluor, and then we just write ic at the end. And then acid, because it's an acid. You have to specify it's an acid. So HF would be hydrofluoric acid. If you want to pause the video at this point and try these out by yourself, you could. And then I'm just going to quickly give another example because I don't want this video to be super long, or else you're going to die of boredom. So the next thing is, let's try to name HBr, which is basically the exact same thing. Now, before you name your acid, you need to obviously identify which one's a positive ion, which one's a negative ion, and you should know in an acid the H plus is obviously the positive ion, and the other one will be the negative ion. So here H is positive 1, and bromine is a negative. And so you have to write your hydro in, hydro, and then the root of the negative ion, which the root of bromine is brom, and then write ic at the end. And then just write acid so that people know that it's an acid, hydrobromic acid. We're done with the first case. We can tear this paper up, burn it, whatever, you know it now, hopefully. And let's get to case number 2, or in German, they say zwei. I hope I said that right. Please, again, don't sue me. Case number 2 is when you have a positive hydrogen ion, so for example, H plus, and it is bonded to a polyatomic ion, which you should know at this point what a polyatomic ion is. It's a molecule where the entire molecule has a certain charge. So case number 2 will be when the H plus ion is bonded to a polyatomic ion that contains less oxygen, that contains one less oxygen. And I'm going to explain that because that might sound a little confusing. For example, I'm just going to finish this, polyatomic ion that contains one less oxygen. Oxygen. For example, the polyatomic ion sulfate has a charge of 2 negative, or -2. But there's also another polyatomic ion that looks incredibly similar to this one, and it's called sulfite. It just has one less oxygen than sulfate. And I'm just going to write their names. Some people write it with a PH, other people write it with an F. Again, don't really care. And sulfite, which has one less oxygen, as you can see, right? 3 is 1 less than 4. Sulfite has one less oxygen than sulfate, but both of them have the same charge, right? 2 negative, or -2. In this case, because we know that there's 2 of these sulfur and oxygen, 2 of the polyatomic ions that contain sulfur and oxygen, case number 2 would say that we are, in case number 2, we're using the one that has the less number of oxygen. So the one that has one less number of oxygens in it. So in this case, we would use sulfite. And so we have H plus bonding to SO3 2 negative. And at this point, you should already know the crossover rule if your teacher should have taught that to you at this point. You're just going to cross over their charges so that the charges cancel out to 0, because in an ionic compound, charge has to cancel out to 0. And so this would be H2SO3. That's your acid. And to name it, how do you name this? Basically, you just know that because the ending of the polyatomic ion that contains one less oxygen is ite, you will change ite to OUS. That's it. So you don't put the hydro in front. No hydro in front. All you will have to do is the name of the polyatomic ion that we're using here is sulfite. It's the one with one less oxygen. You will just change that to sulfurous. That's it. Keep the root, change the ending. If it's ite, it becomes OUS. Now let's move on to case number 3, where you have H plus ion and a negative ion, or a polyatomic ion that contains oxygen. The negative anion is a polyatomic ion that contains the most oxygen. So I'm going to continue with the example that I gave about sulfate and sulfite. As you can see, sulfate right here, our friend sulfate, actually sulfate is probably not your friend. Hopefully you're not friends with a chemical, substance, but sulfate contains one more oxygen than sulfite. How do we name an acid that contains the most oxygen, right? Because we have one that contains less oxygen, we have one that contains more oxygen. We have let's see how to name it. So we have an H plus ion, and we have SO4 2 negative. Again, we're going to do the crossover rules to balance the charges and make it equal to 0. This becomes H2SO4. How do we name this? Well, because this anion is called sulfate and the ending is ATE, all we have to do is we keep the same root. Root is kept, right? We don't change the root. And again, like case number 2, we do not put a hydro in front. We keep the root and we change the H to ic. And I'll tell you a way to remember this that you might kind of find funny or stupid, but it helped me a lot. So this acid would be called sulfuric acid, right? Where we kept kept the root. We just added IC at the end. And obviously you have to add that it's an acid because you need to state what type of a substance it is. How do you remember that 8 becomes ick and ite becomes OUS? Well, I can tell you a way to remember how 8 becomes ick. IC could stand for ice cream. I ate ice cream. That's how I remember it. 8 IC. I ate ice cream. So there's 3 different cases. The first one where you have just a H plus ion and a negative ion, or in other words, an anion. You need to be very familiar with these terms that does not contain oxygen. For example, H and Cl negative, H plus and Cl negative bonding. In that case, you just write hydro, the root of the negative ion, and then ick. That's it. That's case 1. Case number 2, quickly, is where you have the polyatomic ion that contains 1 less oxygen. In that case, it would be called something ite, and you just change you keep the root, don't add hydro, you keep the root and change the ite to OUS. In case number 3, where you have a hydrogen ion, H plus ion, obviously because it's an acid, H plus ion with a polyatomic ion that contains 1 more oxygen. In that case, you would just change the 8 to IC. And that about sums up this video, and I want to just wish you all a nice day. Have a nice day, and I hope you understood this. If you have any questions, you could of course leave them in the comments down below. And have a nice day, and this panda is very happy today too.